Hello and welcome back to High Fell. First of all, thank you very much for all those people who watched the last videos. For me, it's been quite a popular one. Also, thank you very much for those people who liked and subscribed. Quite a lot of comments as well. So hopefully you're finding this all useful. Just something to remind people of, my channel is all about being positive, a can-do attitude, fixing problems, showing you how I've done stuff and sharing ideas. If you want to have a negative rant about a particular manufacturer or something like that, take it somewhere else, because I'm not interested. And I don't think most of my viewers are either. It's getting a little bit tiresome in the hobby and we just need to move on. So there are some problems with the motors that people have identified, and they seem to have around about a 30 to 35 hour life. This is my model of Trigo, which is still running fine at the moment. It did have a little bit of a jerky stop and start few moments a while back, and when we get into this, I'm anticipating that when I take the end cap off, I think I'm going to see that at least one of the fingers on the BE brushes, that's the technical name for these precious metal wiper arms, will have let go. And the reason why it was sticking was probably because it was caught in the commutator, in the gap between the segments. So that's what I think there might be in there. On the last video, I showed you how I swapped an entire motor to a 12 volt similar specified motor, so it's still got the BE brushes, and basically what we did was we swapped the worm drive on, resoldered it in, and it all runs absolutely fine at the moment. But of course I do expect that it will suffer the same consequences or the same fate, in that the brushes themselves will wear. They're just not really suited to a lot of stop start and reverse. That seems to be the thing that kills them. Also, I did briefly sort of demonstrate how you can just take the end cap off and swap it, and I have another A4 which has got, I simply swapped the end cap. So I bought a selection of these 12 volt motors. They said they were about, I think, £1.60 they are on eBay, and just swapped the end cap with the brushes in. It's a really straightforward thing to do. It means you don't need to remove the worm drive, but of course, again, if these brushes have a similar operating life to the original equipment ones, you know, it's not a fit and forget part for the rest of its life. You have to treat it very much like fitting tyres on your car. They'll last for so long and then they need changing. So the purpose of today is, I said we're looking at various other alternatives. I have got some more other motor alternatives. I'll get my words out the right way around, and they are on the way, and hopefully they will be a long-term fix. This is a 6 volt carbon brushed motor, and when I get the end cap off this, you will see the difference between carbon brushes, and I'll show you against the BE brushes. But of course 6 volts is no good for a 12 volt locomotive. So what we're going to do is swap the end cap with the end cap on this original equipment motor. I have already done a little bit of a test. I've also sacrificed a motor as well, just to see how aggressive you can be taking things apart. And this is a hybrid, so I've taken part of the 12 volt system from here, so the armature, and I've swapped the armature into the 6 volt casing, because you will notice it has got this hole here, which I have a feeling is intended for the carbon deposits to either evacuate or to provide some cooling. This is something I might try a little bit later on. This does seem a little bit more draggy, so possibly the magnets are slightly different as well on this 6 volt one. But for today, we're going to fit just the end cap. You will notice that if you get to these side by side, they are slightly different. The first thing is the 6 volt one. If I can get that lined up, you can see the colouring on the black end cap. The end cap is slightly bigger. It's about 0.3 of a millimetre deeper. However, that's not a problem, because if I just take this 6 volt one, it's a snug fit, but it does pop straight into the chassis. There's no filing required. no cutting of the end cap, no bending of anything, so that shouldn't necessarily present us with a problem. The actual steel case is exactly the same length between the 6 and the 12 volt ones. It's just the plastic end. There is another difference, and this is where it gets a little bit more fiddly, and you might think as I go through the video that it's not something that you want to entertain, which is entirely your choice. You can see that the end cap here, it's a single shaft motor on the 6 volt one, and so it has got a little silver, I think it's stainless steel, blanking plate, and I presume the end of the shaft actually runs up against it. There is a bearing inside, just like there is here, just a plain bearing, nothing too fancy. Apart from that, it's pretty much the same. It's when we get inside that you'll see the difference between them. So this is an A3 chassis. The running gear is the same as on the A1, slightly different to the A4 that I showed you before, because you don't have the mechanical lubricator to remove. So this is as per the instruction sheet that comes with your model, the servicing sheet on how to get the body off. And we've already got it to this state, and I've taken the I've also taken the motor cap off as well. First thing to do is I'm going to identify which is the positive, and I am going to mark the wires, because just the way that in production they've just used black wires. And if you do get these the wrong way around and you are on DCC, you can actually go into CV29 and change the direction. However, I'd rather not. It's just as easy to do it the correct way. I find to remove these, all you need to do is pull a little bit on the heat shrink. Keep this, because this is the bit that you can just slide back over again. Give yourself some insulation against the parts of the chassis here. Now I'm going to pop my iron on in a moment and to get that warmed up. Just going to pop that to there. So I'm going to turn my iron on, get that up to temperature, and we're just going to remove this motor, and then we shall have a dig into the 6 volt motor on the end cap, and I'll show you the differences there. So the iron is back to temperature, and all I'm going to do is heat up the solder and pull the wire off. If you're a newcomer to railway modelling and you haven't mastered the art of a soldering iron, absolutely this could be one of the most useful things you have. Well worth watching some really of the really good instructional videos on how to use a soldering iron that are online, and practice. Get yourself some decent kit, have a practice. Such a useful skill and a piece of equipment to have. So I've removed the the motor now from the chassis. The next thing to do is to open up the back case, the end cap of the motor. And the way to do it is with a nice small, just the right size to fit in there, flat blade screwdriver. See, that just pops in there. What I'm going to do is just get it underneath this little tab and just carefully rock that from side to side, and that will gently lift. Be careful with this, because you don't want to break these tabs off, because we do want to reuse these. If you do break it off, then the problem that you're going to have is the weight is either to, you're going to have to remove the worm gear to replace the case with the one that you get with your 6 volt motor, if that's the way you feel about going with it. So you can see I've just literally pulled that away, and this is the one that that was having a bit of a stop-start moment, and well, predictions are correct. I'm going to see if this will pick it up. I'm going to check which one it is. It is the negative again, and I'm not sure whether basically we've lost 2 of the tiny fingers. Got something quite thin to point out with. So using this, you might be able to pick it up. We've lost 2 of the fingers on the BE brush in here. There's 1 left, so that's all that's working, and only 1 on the positive as well. So despite this actually running quite nicely, that was clearly what was going on when it was starting to fail. Not sure if, see if I've got any. Nothing's coming out, so it's obviously chewed it up and spat it out wherever. And if I look at the commutator, that's got quite a bit of black on that. So I will give that a little bit of a clean. So, and that's actually marked up. You can see that they're literally acting like scrapers. So in one direction, where the brushes will be trailing, it shouldn't work too badly. And then in the other direction, where it's starting to pick up against the edge of the broken fingers, that's probably where we're getting some hesitation. So in your model, if you notice that it's running really badly in reverse, that's probably a good indicator that the brushes in the motor are failing, even though it might still just be working. I mean, this has been hanging on. So my option is I can either replace this with some of the existing Type BE brushes, which is a really quite straightforward swap. But what we're going to do, say for the purpose of this experiment, is swap it over with the carbon type. And hopefully, if what Carl at Hornby was saying, this is what Hornby are intending doing for forthcoming 3-pole motors. I know when it was released on the J50, which is on pre-order, due at the end of the year, he did actually make a point of saying that they will be using a motor with a carbon brushes. So hopefully they've sourced something. It would be interesting to see as well whether these are going to be available as spares or service items that would also be suitable for going in these models. So these are a little bit more difficult to remove because there's quite a bit more tension. There's a little cutout here on the side and a moulding which you can just prise it slightly, and then as I remove this, just carefully slide this, and then what you're going to see is the insides are quite different. So this is a relatively new, this is the one that I got out of Silver King that wasn't really working very well, and that was the replacement motor from Hornby. And this is the carbon brush type. So the big differences are, I'll get my little pointy wire. Now some people have got slightly different motors. They can look a little bit different, but the main thing is the fact it's got these carbon brushes attached as opposed to just the wiper fingers, which we know do not really like stop-start work or going in reverse, which is not ideal for a model locomotive. I'm sure these are perfect in radio controlled cars or even slot racing cars where you're generally just going in one direction, and they probably give reasonable service life, but it does seem to be the stop-start and going into reverse that they don't like. So we saw that the motor is actually slightly different on the back, and what we need to do is remove both the brush, sorry, that cap and the bearing, and then replace the bearing. So I'm going to set it up for that, and we shall attempt to swap those over. This is quite a fiddly process, so for some people you might be thinking, oh, I don't really want to get into that, but let's see what we can do. So I'm just using the tweezers to hold the springs with the bushes on pull them back. Can be a bit fiddly. I'm sure it's going to get a bit more testing in a moment. If you're wondering why I'm not getting motors that have the jaw shafts and the carbon bushers, so far they're not available. If anybody's got indications or ideas of where you can get them in 3, 6 or 12 volt, it doesn't matter, because we're only going to be using the end cap and the brushes, do please feel free to mention it in the comments. I shall have a look and try one of those. It certainly would be an awful lot easier. So there we go, just to prove it doesn't always go smoothly. And then with the other tweezers, I'm just going to pop this back into here. And for now, just going to get it quite level, and there we go. So that bush, that bearing if you like, is only just sat in there. And then what I'm going to do is I'm going to use the puller to press it back in. And the reason why I want to do that is, with these plastic end caps, it would be very easy. And when I say it would be very easy, you know I've actually tried it and managed to bend one. It's quite easy to get this bush to go in at an angle, and all it'll do is it'll just squash up against the plastic, and you'll probably ultimately end up breaking the carbon brushes as well. So first of all, just bring the pin down to the level of the bushes. You'll notice I'm using the slot here to take up the gap of the, or to make a gap for the contacts to sit in so they don't get bent over. I'm just going to roughly line that up where it needs to be. Just come this way a little bit, and then we're going to just again use the tweezers and simultaneously push the contacts apart and press the bearing in, which is easier said than done. Right. Oh, you annoying thing. Always said that railway modelling is full of opportunities for mindfulness and concentration. So you might not be able to see desperately well, and it's a bit difficult because it's a fiddly job and I'm trying to see to do it myself. I'm not a special YouTuber with all of his production crew and cameras and microphones. Right, I think we're in. We are, right. So, the pin is now up against the edge of the bush, or the bearing, whatever you want to call it, and then the actual carbon contacts are either side. And then all we're going to do is very gently wind that back in. Get a bit of light on it, see if we can see what we're doing. It will go in very easily, doesn't need much at all. Just a little bit of pressure to make sure it's seated home. Remember, these are only small components, so you don't need to be giving it too much aggravation. Right, so we've actually got the bush back in place, and so far we've managed to do it without snapping the carbon brushes off the springs. So the next part of the job is to actually get this and get these over the top. But remember I said that this commutator doesn't look particularly clean, so I'm just going to use a bit of IPA and give that a little clean up and make sure that we haven't got any bits of the old fingers floating around in there. So some IPA and a cotton bud, and we'll clean that up. So here we are. What I've done is I've actually cut the end of the cotton bud off, so that one of the great things of environmental law is that cotton buds now are made of cardboard rather than plastic. So if that soaks in a little bit of IPA, we should just be able to gently clean that off. Again, just be nice and gentle with it. There will be a soldered contact which goes to the wire on the windings round that makes this work as an electromagnet. Now that is actually protected, but you do need to be very careful. As I'm doing this, I can actually feel quite a set of grooves in this. So I'll be absolutely honest, I am not necessarily thinking this is going to be a long-term fix. I think the failing bushes have probably damaged the commutator surface. Now the carbon will wear down to that, but if this is a coating on there rather than solid, that might not necessarily be very good for the motor. So giving that a bit of a clean, and the most testing part is to get this to seat. So on the so now comes the tricky operation, which is trying to get these brushes to actually engage with the commutator. So first of all, I'm going to line it up with the bearing, which in itself is no mean feat. And then I'm going to use tweezers to just lift slightly. You have got a tiny amount of room afforded by the slack on the worm gear and that sort of bit of shaft that's free. There we go. It's really hard to try and explain and show you on video like this, but if I pick up one, here's a damaged one. When you're putting the shaft of the motor in, what you're trying to do is get this just to lift back so that it'll clear the commutator, and if you keep a little bit of pressure on the end cap as you do it, it'll just hold it apart. Once you click the other one in, it should just go on nice and freely, and that shouldn't feel too bad. There we go. So remembering that we've still got the little tabs to push down, I'm going to use a screwdriver just to drive those over. It helps if you put the pressure on in the right way, and I'm just going to use this to help me again. So I'm going to not actually going to push on this like as such. I'm just going to use that to hold the casing. And then push the tabs over. Do make sure you have got them on, because as soon as you put this in, if it isn't correct, it will start to flap about, even though it's quite a snug fit. still pushing away, so we still need to be a little bit more. Maybe a bigger screwdriver blade will help. Obviously, do take care of your fingers. That should secure it on. Yep, that's nice, and that runs quite freely on there. As you can see, I'm just going to show you how I've done this. Again, I've used this just to support, because I'm using the this cover here too, or this end plate, to support the casing of the motor, so that I can push the whole thing down without pushing the end cap back up. I want to actually force it down that way. So that's how we use it there. So even if you're not going to be pulling the worm wheels off, this is actually proving to be a really useful tool in other ways as well. I don't think they're desperately expensive. I think they're about, I don't know, 16, 20 pounds, something like that. Right, so the next thing to do is to pop the soldering iron back on and get this up to temperature. Right, so we're going to get ready to solder the contacts back on. Again, if you're new to soldering, I do really recommend looking at some of the really good tutorials on the Hornby Forum. One of the missed members of the forum wrote a lot of really good work on how to solder, but there are some really good tutorials as well on YouTube, so do get a look at that. Now, I always use a little bit of flux just to help things flow, and so I've already put a little bit of flux paste on, and what I'm going to do is I'm just going to use this, make sure my iron's clean. Just going to get a blob of solder on here. This never goes quite as easy when you're trying to do it on a camera. Right, there's one on there. I did this last time. It's a lot easier just to hold it here. There we go. Nice little dab of solder. So we're going to have a look and see which is the positive and negative. So the positive's there, so negative is at the top. We'll pop that on first. I say, if you do get this wrong, it's not the end of the world. You can actually change it in the CV, or you just resolder it the other way around. So just carefully dab that there. Just going to go in, I'm going to clean my iron a bit, and make sure we just clean that up a bit. Yep, all good. And then, just whilst it's warm, I'm going to pop a little bit of heat shrink over so it doesn't get forgotten. And then I'm just going to flip the motor over. This is it's going to be its final position. Well, I say final position, if all this works, it'll be its final position. But that's the correct orientation. Remember, I've got my little red marker on there just to remind me. Well, in fact, not so much remind me, to tell me, because there's no way you'll be able to tell with all the wires being black. I think some of the later models have actually got coloured wires for the positive and negatives, but there we go. So, same on this one. Just give the iron a little clean over and hold it on. it's nice and secure, which it is. And then feed this round. Come on, there we go. Just apologies if it goes out of shot. Right, there we go. Right, so that's now the motor soldered back on. Seated it in here. So the next thing to do is to put the cover on and make sure that that is locating properly. Be very careful again, this is a cast material, so if you don't get it lined up properly, don't force it, because you will break that casting. And then you'll be making another phone call to Hornby Spares for some more parts. So just loosely pop the screws in. Remember last time I used some helicopter tape, and that's because the little bit of foam packing had melted as I tried heating the motor up to remove the worm. I think on reflection now, I think the heating idea, I think it's too hard to get sufficient heat in the right place, and using the combination of different length pins is the way forward. And if you're hearing some background noise, that's just the sheets in the washing machine. Right. Okay, so we've now got the motor in. Going to test it with on the layout, and first what I'm going to do, pop the plug back in. I'm going to test it without putting the body on. I always think if you put the body on something, it's almost like asking for it not to work. Sure you get this the right way around. Again, never force anything, just offer it up gently. And once it's going to go into place, it'll just seat home. Again, I've probably said 100 times before, these little cranked pliers, tweezers are so useful for doing various little jobs. Right, so that's on there. The other thing I was going to do is I will put the drawbar on, and then I'll pop something down so that it doesn't pull on the wires. Here we go. Right, so I'll pop something of a pin through there when we're actually on the layout. So, oops, out of shot again. One of my favourite things, out of shot. So, to the layout, and let's see how this works. So, the moment of truth. Locos on the layout. We'll run it without sound so we can hear any grunches or any noises going on. I've just used one of those pins that I damaged previously, just to stop the drawbar from hanging back and it pulling on the wires. Got the right address in. Oh, there we go. Give you an idea. that is on 1. So that's pretty good response there. I'm just going to hold up the tripod, move it around a bit so you can see. So we're on 9. It's running quite nicely, that. And I'll take it up to about 3/4 of speed and let it run in. It's certainly running quite smoothly, and it's not excessively noisy. I was a bit concerned because one of the descriptions of the difference between the carbon brushes and the BE ones is the motor manufacturers claim that the BE ones are more efficient, quieter and smoother running. Well, yes, maybe they are. I do wonder whether perhaps some of these motor manufacturers have been selling products to our model railway manufacturers, claiming all sorts of wonderful things without them necessarily being true. I mean, who'd ever imagine that of a component supplier? I have to say I'm actually pleased with that. I think that is satisfactory. So the next thing to do will be to run this and see how long it likes the carbon brushes. So 30 hours to 35 hours seems to be the life of the BE ones. I mean, this loco ran exceedingly well until it didn't, and then it kind of cleared itself, and I don't know whether you were able to see on the video. I had a look. I knew what I was looking for, so it's easier for me to see, but yeah, that was clearly what was happening. The actual little fingers on the brushes were breaking down and disappearing off to goodness knows where bits of brush disappear. I was a little bit concerned that that marking on the commutator might give us a less than ideal running, but so far it doesn't seem to be an issue. And I'm actually just going to bring this up and we'll see what it's like in reverse. I have noticed that sometimes these models, when they're new, their reverse is not that good. But I'm going to say this is 100 times better than a brand new one. Bearing in mind these brushes are brand new, so they're straight out of the box. You into the same idea as you would be with a new locomotive or a new model you're running it in. That was on speed step 11. If you are running with a HMDCC controller, speed step 11 is not the same as your 11 on yours. Those on traditional DCC will understand. The speed is divided into 128 speed steps, although you only really get access to 126 of them. And also I throttle my locos down as well. I set their maximum speed to what the in-service maximum would have been, so you get much finer control over the other speed steps. But also, these are model railway locomotives, they're not scale electric cars. So, from that, I'm going to call this little experiment a success. And so for the next thing I'm going to do is we're going to see how we can keep an eye on the temperature this runs to. Somebody did make a comment that 5 carriages is about the load limit of these before they start overheating. So to that part of the experiment next. So we're back on the bench and, well, bench, dining room table really. So what we're going to do is going to have somebody just to keep an eye and see what kind of temperatures these motors build. Now I realise obviously I've put the carbon brushes in and some people might say, oh, it's going to be different. But logically, I can't see why that is. So what we're going to do is we're going to use some telltale temperature strips. And because there's no point in having loads of this on. What I'm going to do is I'm going to trim these down. I don't need it to tell me the temperature because I'll work it out from the other side, from another sheet rather. You can get all sorts of ranges of these, very, very useful for all sorts of projects. Used a lot in engineering just to get some idea. Say it's a telltale strip, so what will happen is it should colour the highest temperature it reads, and I'm just going to pop this on top of here because I think this is where we're going to get the most amount. I say, when somebody had mentioned about the temperature build-up, I did actually have a good look. Now, I have to be honest, I can't see anything that remotely resembles excess temperature. It normally leaves some kind of witness mark inside, slight discoloration of the plastic. Sometimes you get sort of the glue starting to lift. In extreme circumstances, obviously you'll get plastic starting to deform as well. Just something to indicate. I also took the advantage of adding as much weight as I could and even filled behind a smoke box door with some lead shot on there. So yes, I do overload my locomotives. Right, so next thing to do is to fit the body and let this run. I'll give it some more running in and then keep an eye and see how it works. So thank you very much for persevering this far. Hopefully my editing will be a little bit better, although I never promise anything fantastic on the editing side. It's not really what I'm about. Please keep the comments coming. If you are feeling you want to have a bit of a pop at Hornby or something like that, don't bother. I'm not interested. I'll just delete your post. This is for people who are interested in the hobby, interested in model railways, wanting to make the locos work, wanting to have fun with the hobby, and basically encourage others as well. So that's where we are with that. So please like and subscribe, do share, and check out some of the other content as well, particularly say Garry Hall, who's got some a fantastic array of models. I know he has converted one of his A4s to run on these brushes, and another big thanks to DJB Doug from the Hornby Forum, who was one of the ones. He's been repairing a couple of shunters, and he's been messing around with various motors and doing some stuff. So he's been obviously a leading light in tracking down bits and pieces. We've all been working towards it. It's a joint effort, and so thank you very much for that. I'm going to presume your name is Doug, but that's me done for now. Body on, and do take care and happy modelling.